welcome to our fireside chat beyond Earth's atmosphere, navigating regulations and security in space. For some housekeeping, everyone has been muted, but please feel free to add questions to the chat throughout, and we'll answer them at the end with a live Q&A session. Today, I'm really excited to welcome Joe Saunders, founder and CEO of Cybersecurity, Sam Beisner, Techno Fellow at Aerospace Corporation and Chair, Board of Directors of Space ISAC, and Dean Weber, Director at AlixPartners, as they explore the complex landscape of cybersecurity in the space sector. Joe, please go ahead and take it away. I'm excited to hear this discussion.
All right, thank you. I'm Joe Saunders, founder and CEO of Cybersecurity. Welcome Sam and Dean, so they'll come on video now. And with that said, RunSafe protects critical infrastructure from cyber attacks. But more importantly, to set the stage for today's discussion, there are some estimates by 2023 that, and I've got three numbers up here, 25,000, 500,000, and 5. And they represent perhaps one way to look at the need for cybersecurity in space. And that is that by some numbers project by 2030, 25,000 satellites will be launched. They will be carrying 500,000 petabytes of data. And we already have at least 5 agencies initiating programs to protect space assets essential to all domains. And so with that, I look forward and welcome the panelists, Sam and Dean, and we'll just jump right into it. So welcome, Sam and Dean, to this discussion. We appreciate not only what you've done in the past, but what you're doing today, especially in the domain of space security. And with that said, I thought, Sam, maybe you could kick it off. If we could just sort of do a grounding question, if you will, of why is space such a contested environment, and what are the implications for cybersecurity?
Joe, thank you. Great question, and let me try to give a useful and concise answer. So, first things first, space systems are important to every aspect of our national security, which includes the work that space does for the Department of Defense, for the intelligence community, but also for our civil agencies, NASA, NOAA, space weather, understanding the effects of weather of global and U.S. meteorology, climate change. And lastly, and perhaps even most important, space systems act as a technological forcing function for the rest of our technical industry, and all of our critical infrastructure depends on space. Precision agriculture, so that we know where to plant the condition of soil using IoT devices that communicate through space. Remote sensing to take a look at ground conditions. GPS, not only to navigate the truck from the farm to the supermarket, but the combine harvester to exactly the right place on the farm where it needs to be cultivated. Our transportation system, our healthcare system, our energy infrastructure all depend on space. This is work that we've done with the Department of Homeland Security. So without space, we are no longer a global power. We're no longer a global economy. We are no longer a globally important country. We're no longer a leader. And other countries understand that. So as they are attempting to assert their own preeminence in the world, in the international system, to reshape the international system or disrupt the international system, they are contesting our leadership in space, both by developing the means to be our peer competitors in space with their own technology and their own systems engineering, which the Chinese have demonstrated their own ability to do systems integration, and in their ability to attack the systems on which we depend. And the systems on which we depend are going to be worth perhaps $1 trillion to our economy by the end of 2030, if not before. So with a growth rate of the space economy double that of our national economy, with space comprising an ever larger component of our economy, we are both more dependent on space, and because we have not addressed the entirety of our security needs, we are facing increased vulnerabilities. So I hope that's a good starting point, Joe, for this discussion. Thank you.
It's a tremendous starting point. And, given the strategic nature of space, as you've outlined, and all the implications, it may be worthwhile, Dean and Sam, if we look at what are the most significant cyber threats then currently facing space assets. And Sam, you mentioned vulnerabilities. What outcomes are attackers seeking, or would attackers seeking from your perspective, Dean or Sam?
Well, let me start here because I have just a little bit more recent experience. We're seeing threats in at least two regards. One, we're seeing threats against ground stations because ground stations represent a more vulnerable and more accessible and potentially more vulnerable component of the attack surface for space systems. And it should be noted that before Russia attacked Ukraine on the ground, they attacked Viasat, which is one of the space systems on which Ukraine depends. But we're also seeing the ability of countries to threaten space systems on orbit. We're concerned about a Russian satellite, Luke-Olymp, that maneuvered in geospatial orbit and blocked the transponders on European Eutelsat communication satellites. We could actually see that the space ISAC, both the diminished strength of the transponders of the target satellites and the movement of the attack satellite of the Luke-Olymp satellite. So we're seeing potentially attacks on orbit. And the outcome that they're seeking to have, less confidence in our ability to use these systems in time of war, thus to deter us from attempting to deter them. The ability to undermine our critical infrastructure, including our ability to undertake military modernization or military mobilization, or to be able to sustain our critical infrastructure under conditions that an adversary might seek to impose. There are a whole range of things, including the possibility of simply using ransomware to make it impossible to use these space systems and to gain financial advantage from that. Nothing can be overlooked in terms of what these people are capable of doing and how little conscience they demonstrate. Let me stop at that point and turn it over to Dean.
Well, and I'll add a little different aspect to that from the technology standpoint. The technology components are relative to how does one address the systems, both in space and on the ground, and whether or not those systems are trustworthy or can be compromised at a code level or can be compromised at a function level. Sam mentioned Viasat. Viasat was a denial of service attack, pure and simple. They prohibited people from using the internet to gain access to information in times of stress. That's a relatively simple aspect. If you look at something like SolarWinds, where we're actually doing source code level attacks at the platform level, at the application level, or potentially even at the system level, if you look at some of the AMD and Intel functions that have been compromised over the years, the reality is that there's several different components that can be attacked or attack vectors that can be utilized to damage or disrupt the spatial systems. So, whether we're communicating with a satellite, whether we're updating a satellite, whether we're providing a new platform to the satellite, because again, we got a lot of satellites in the air. It sure would be nice if we could repurpose them over time for various functions, as opposed to dedicated function incidents that we had to put in space and then leave them there and basically not update them because we didn't have the capacity to connect to them safely or securely.
Yeah, and I think you're getting to a key point there, Dean. Building on the foundation Sam established, and I guess could you take that step or that thought one step further, and maybe summarize from your perspective, and certainly Sam, you as well, what are some of the unique cybersecurity requirements as a result of both the interesting aspects of the attack surface, but also some of those considerations about the purpose of those platforms that are in space? So any unique requirements that you think these assets have, first from a cybersecurity perspective?
Sure. So again, if we're launching dedicated platforms to dedicated functions, that's one aspect that has, do we have the capacity to connect to and communicate securely to and from those assets in space? So that's connectivity functions. As we move forward and we put more robust communications capabilities into the platforms and the ability to change the workloads, either through virtualization or containerization, or even further down the road, if we start talking about the ability for these platforms to change their own functions through machine learning and AI type functions. These are all things that are going to be rooted in trust, or must be rooted in trust, in order for us to have faith that the actions that they are performing on our behalf are actually useful and are trustworthy. Does that answer the question?
Absolutely. Anything to add there, Sam?
Yeah, I would. Dean called it out very clearly. Space systems present some unique challenges in terms of security. First, any space system exists within a very tight envelope of space, power, weight, and cost. SWaP-C as we call it. So, if you add a security feature, are you adding cost? Well, who pays for that? The customer, not happy. The investor, who's been promised a return, also, by the way, not happy. Are you going to add power requirements? Well, if you do, that means you either have to make a bigger spacecraft or you've got to reduce power available to some other systems. Are you going to be diminishing some other mission capability while you add security capability? Are you going to be adding weight? So as you take a look at space systems, every space system is a delicate balance of many factors, including when it needs to launch, either because it has a mission to fulfill or there's a value proposition that has to be satisfied within a certain time, or that investment doesn't work. The business case fails, or if it's a national security or civil mission, that mission doesn't launch on time and we don't get what we need out of the mission. So space systems are not necessarily easy to secure. And for people who are very concerned about getting the mission up there on time, making sure that the mission launches, making sure that the mission has the functionality that it needs, security may not be the top of mind concern that cybersecurity professionals like Dean Weber and others and myself would hope that it would be. And people who have other expectations for their mission, like it launching on time, having the functionality that it's been promised, existing within the cost structure customers are willing to pay for, and giving the return on investment for systems that are very, very expensive and difficult and expensive to develop, deploy, and operate, those are also legitimate concerns and they can't be dismissed. It's for this reason that I've called for a national R&D strategy for the cybersecurity of space systems that unites industry, academia, federally funded research and development centers, and government, because I think we're going to need to do this if we're going to make these systems as secure as we need them to be, and at the same time, do so in a way that doesn't make that security unaffordable or unfeasible.
Yeah, both of your points make it very clear that the technology and the economics converge here. And so if we think about repurposing and reprogramming and extending the life of missions and satellites and assets in general, then you can see that security does play a role if these economic and technology interests are to be advanced and realized. And so as you consider power, weight, and cost, as you consider the mission, as you consider the technical aspects of repurposing, then security does certainly play a role to help establish that further resilience and extending the life. And so with that, I think another convergence then that we've hinted at is the mixture of the national security interest in space with commercial organizations. And you started to mention that, Sam. And I wonder, what are the implications if commercial organizations own and operate the technology? What are the implications for national security?
Well, first, it's nothing new. Government doesn't build a lot of rockets and satellites themselves. They might build some, but overall, they turn to industry. So they turn to the supply chain, to the defense industrial base, to our technology industrial base to build these things, and they have pretty much from the very beginning. So there is a stake in the cybersecurity of systems built by industry for government use. And it's for this reason that there are various government working groups that are supporting the cybersecurity of the industrial base on which government relies to purchase these systems. Take a look at systems like Nestis and look at systems that are used for communications. All of these systems are built in industry. But now government also buys services. Government is buying communication services from companies like Starlink with a constellation called, I think, Starshield. They're buying imagery services from Planet and Maxar and Black Sky and others. They are buying services that supplement the services that they get from their own satellites, which again were built by industry. And the implications here are fairly positive implications. It gives the government more capability than it would have had before, not just its own satellites, but other satellites. It also means, there are more platforms, more diversity of constellations, more diversity of platforms within those constellations. They're not all that easy to target. The Russians went after Viasat. They've gone after Starlink. Frankly, they haven't been all that successful. These systems have proved to be resilient. How do you go after a constellation that has 12,000 and eventually maybe 40,000 satellites, right? With thousands and eventually perhaps millions of ground stations. These are going to be very difficult systems to disable en masse. But at the same time, it means that industry and government are going to have to work together more closely than they ever have. It's not just industry being told you're going to have a secure supply chain for the parts in the satellite that you build for the government. It means that both of them are going to have to work together for standards, for tighter cybersecurity of the industry systems that are used, from which the government buys its services. This is hard work. This is going to take a lot of cooperation. The Space ISAC, the Space Information Sharing and Analysis Center, the board of directors of which I chair, is bringing industry together with government partners, both US and with our allies and partners in the UK, France, Israel, Taiwan, Germany, Australia, Greece, and hopefully soon some others, to work on this problem, because this is a shared problem and the stakes are shared by all, Joe.
Absolutely. And with that, maybe we could go a little deeper on any regulatory angles here. And so, with space policy directives, how are current regulations addressing the unique cybersecurity needs of space technology and assets?
Well, at the moment, it's not a regulatory issue. Space Policy Directive 5 from the prior administration, which has been sustained in this administration, sets out a series of controls that are desired, that are recommended. But there isn't a lot of regulatory muscle behind it. And there isn't yet a consensus in industry as to how much regulation should be needed. Now, having said that, there is a new executive order coming out. I haven't seen it, but I'm told that it will likely propose minimum viable cybersecurity standards. Where those standards will come from? Well, the IEEE has put together a working group under Greg Falco at Cornell, which is working on the cybersecurity of space systems. I'm co-chair of one of the sub-working groups, the one on the user segment. So as government calls for minimum standards, industry is working to develop standards through bodies like the IEEE, which I think is among the most prominent, to make such standards available. I can't speak, Joe, to what regulatory approach might be used, because frankly, I think industry is hoping that this can be done effectively on the basis of what is a best practice, as opposed to what is required through a regulatory approach. And since the standards may evolve more swiftly than regulation, it's possible that that'll be the wiser approach in any case.
Yeah, no doubt. And I do think we want to get to some future developments, some solutions and enhancements that we can have to our security posture in just a minute. But maybe one more question for you, Sam, on just the space ISAC, since you did bring it up. What role do you see the ISAC playing in cyber threat intelligence for the sector, and how can it be enhanced going forward, given all the interest from the countries you referenced?
Well, Joe, again, a great question. And the Space ISAC is absolutely key. We're the ones now setting the threat level for the industry. We are the ones who are taking all sorts of information about cyber threats, orbital anomalies, space weather, things related to the supply chain, and correlating them. Are we seeing an orbital anomaly that might be correlated with a report about a cyber threat? So not only are we publishing all source reports about cyber and other threats to space systems, but we correlate them. Is somebody using a space weather event as cover for a cyber attack? We're the ones who do that. We have now over 100 members, as well as partners with the U.S. government and with the governments of allies and partners. Going forward, we've been successful in gaining the resources for what's called Watch Center 2.0, which has a new set of fusion cells. I like to say that Aaron Miller, our executive director, and I held a bake sale to raise that money, and we were successful. I guess somebody liked our cookies and our cupcakes. So we have been successful. The other thing we're doing is we're going to work with industry partners in Australia and in the UK to set up operational adjuncts to be able to do cyber threat analysis and intelligence sharing, not just in the US, but on a follow the sun and eventually 24/7 model. And our resources have to grow for us to be able to fulfill that requirement, but we now have a roadmap to it, and we've started making real progress in that regard. So that's really what we're doing. And we're providing not just real-time information, but we're also, with our supply chain risk management working group, looking at threats to a supply chain for space systems that's increasingly globalized and commoditized. So that gives you a sense of what we're doing in terms of not just sharing real-time information, but also sharing best practices and recommendations among our members and our partners.
Truly valuable, and I appreciate all of your leadership in that and the team's leadership from the Space ISAC. And so with that said, Dean, I'd like to point a couple of questions your way, get your view on a few things. We talked about, not affecting weight, power, and cost requirements, and ensuring security. So how can we implement effective security measures for space systems without adding, additional weight, power, and cost components to it?
Most of the working components necessary to make a trustworthy system are already resident or could be made resident with minimal muss and fuss. The aspect of trusted execution environments or TPMs in the standard compute platforms that are the basis for much of what is being done on platform in space. These are no longer built for purpose dedicated platforms. They are relatively open commodity type compute platforms because of the nature of the workloads that are being addressed to them. So our ability to build a trust chain that is demonstrable and is conveyable in terms of, is that a trustworthy system? Does it have trustworthy components? Are the applications operating in a trustworthy fashion? And how do I convey that to the consumer and to the receiver? And how do we do that in a bi-directional basis? Because not only does the ground have to trust the satellite, but the satellite has to trust the ground. And those are all things that have to be developed and delivered that can be done, I wouldn't say at the highest levels of security, because again, that requires some more dedicated effort, but we could certainly take a pretty strong approach to overall security aspect by adding in the trust components to both the hardware, the firmware, the software, and the application execution.
Sure, and certainly with the ability to verify that the image produced is the image that runs on a system. That's one way. Also knowing that hopefully none of the files have been tampered with, if you will, as they're operational, and certainly protecting the runtime elements of it as well, also important. But I do want to pull at the thread a little bit further when you talk about, trusted communications and bi-directional communications. How can folks achieve that? What needs to be implemented? And is there anything unique about, I know you mentioned sometimes commodity platforms or existing off-the-shelf software, but what's really needed to implement that to a sufficient level in systems architectures for space assets?
Oh, again, it depends on what the appropriate level is, what the design level is, and we can do a lot for good enough. We can do a lot for pretty darn good. And then we got to put some serious effort if it really absolutely positively has to be known good at all times of the things that we have to put into play to actually achieve those measurements and to convey them to the appropriate consumer. In terms of communication, one of the things that's happened, in the past is that, our high Earth orbit communications is the most expensive communications patterns that we can support and develop because of the distance involved and the telemetry involved to tracking. And as a result of that, those communications tend to take a more lightweight approach in terms of the communications itself and the cybersecurity associated with the communications, as opposed to low Earth orbit where we have a lot of them. And they're available to things other than ground stations, right? They're available to sat phones and they're available to mobile workstations. And the use cases are more broad for low Earth orbit type communications protocols where we can use more standardized communications like an IPsec or an SSL TLS type communications transport mechanism that has the capacity to do conveyance of bidirectional trust in the communications protocol itself. I can trust you because you've given me credentials and knowledge that you are trustworthy, and likewise, you can request that of me and I can send them to you. Now, this all works really, really well right up until the time that we get into the post-quantum world when things are going to get really interesting from a cryptography standpoint, but we'll leave that for another day.
Yeah, absolutely. So, fantastic. And really a final, more technical question for both of you. But what are the key considerations for manufacturers when building security for space technology programs? And you mentioned, Sam, some best practices. You mentioned Dean, sort of depends on what the requirements are. But what advice do you have for manufacturers as they think about what their requirements are?
Well, let me start with two. First, development environments themselves need to be secure. What we've seen from things like SolarWinds and issues at other companies is that if the development environment is not secure, then nothing really is, right? Once something gets into the supply chain, if it's assumed that it was developed in a secure environment and it was not, then as we say, Katie, bar the door. And that can happen. The second thing I would say is the chain of custody. There are good techniques. Some companies do a good job on chain of custody. Others perhaps are not doing perhaps quite so well. But even if something is developed in a secure environment, to make sure that it's not tampered with or something else isn't introduced into the supply chain, being able to have traceability in the environment, I think, is absolutely key. And while I have the floor, I want to make a plea for one other thing, and that is the security of additive manufacturing. We're going to use additive manufacturing to build space systems, and we're going to do additive manufacturing in space to do things like mining, to do things like the fabrication of more parts, in space, in the cislunar environment. One of the things that we've learned is that you wouldn't necessarily call it malware, but a change in the Z code for 3D manufacturing can change the deposition density of a part so that instead of failing 1 in a million times, maybe it fails 1 in 500 times. And since it might be used, 1,000 times a week, it could fail. So it might be difficult to detect that with visual inspection. However, if changes are introduced into the code that is used to control 3D or additive manufacturing devices, if that development environment is not entirely secure, that's another way in which a security problem can be introduced. And you wouldn't detect it by traditional means of detecting malware. You wouldn't detect it through your firewall. You wouldn't detect it with an intrusion detection system. No, you might not detect it at all if, in fact, it was just a very subtle change in the rate at which material is deposited to make a part. So the security of the supply chain, I would say, overall is very important, securing the environment and securing the chain of custody. Let me turn it over to Dean, who probably has a better answer to this, I suspect.
Well, I don't know about it better, but I'll answer it in the same fashion a little differently. The ability to create and manage trust at all levels, at the platform level, at the compute level, at the component level, at the materials level, all of those things come into play. The government historically, when it is really positively important to do that, has done it inside government facilities. That just isn't an answer for us in a broad-based aspect, right? To Sam's point, we have to be able to be, basically a global supply chain, because things are going to come from different people for different purposes under different levels of austerity. And so when we look at the supply chain, we're really just getting started in how to start addressing those kind of things. CMMC is a step in the right direction, right? Our ability for the government to say, you're a commercial supplier, you're part of the defense industrial base. Under these conditions, these are the guaranteed results that I must see from your operations. And I think that can be extended further. I think that could be extended all the way into the CICD pipeline. I think as we start developing technologies terrestrially for deployment to space, that CICD pipeline could actually be extended to space. I know there was some work being done at DARPA a couple of years ago on exactly that project. I don't know what the result of it was, but I mean, at the end of the day, we have the basic building blocks of building a trustworthy environment, and for all the things that we've mentioned, right? Platform, software, hardware, firmware, components, actually the materials that they're working with. We have the capacity to do that. The problem is space is a unforgiving place when we come to go do this stuff. So we have to figure out how to do it right pretty much the first time. And there's going to be some setbacks, but unlike terrestrial type operations where we still struggle with some cybersecurity aspects today, we really need to take a crank on the handle of making sure that we get it done right. Because once it's in space, it's pretty much a foregone conclusion.
And that might be the only addition I would add to the discussion is that it's very, very hard to update these systems once they're launched. And so, with that, the runtime aspects of vulnerabilities, memory-based attacks, things that RunSafe actually cares a lot about. We're on a mission to rid the world and beyond of memory safety vulnerabilities in general. And so, I would just consider, the aspects of the runtime angle attack vectors as something that needs to be locked down as well. And with that,
let me add something to that, if I could, there, Joe.
yes.
Dean points to, CI/CD, continuous integration, continuous development. There are some opportunities, and for companies like RunSafe, they should pay attention to these opportunities. Space systems today are highly iterative, right? If you take a look at some of the mega constellations going up, right, launching 60 satellites at a time, and maybe 2 or 3 don't work, you know what you do about it? Nothing. You wait till the next launch, right? And at some point you say, well, I put up 60 satellites 2 years ago. They've reached end of life. Turn them off, burn them up, because it's time for the next iteration. Better engineering, better power management, more, better use of the available space and weight. So this is an environment where instead of launching something that has to function for 15 or 20 years, we're going to be seeing more and more systems, including national security systems. Take a look at the work that the Space Development Agency is doing with Tranche 0 and Tranche 1 that are more iterative. And this means that the approach to which Dean pointed, CI/CD in the development pipeline, there are going to be more opportunities. So if you think there's a problem with this year's satellites, start thinking about what you'll do with next year's satellites and the year after that. Think about, an iterative development process that says, well, I didn't solve this problem this year, but I think I can solve it next year, and I can do a much better job the year after that. Don't think about this as one and done, because I think in a more iterative space economy, there will be opportunities to improve. And in fact, I think a number of commercial operators are thinking in just that way. They don't want their satellites to operate forever. Their business model doesn't actually take account of that. It accounts for the iteration and reiteration of an evolution and swift evolution of their constellations and their overall infrastructure. Full stop.
Yeah, no doubt, and totally agree. And of course, from our perspective, leveraging those high velocity release schedules, DevOps, best practices and whatnot. It is different to say, hey, I'm doing 10 updates a day versus, 1 a month or 1 a quarter or 1 every 6 months or 1 every year. So no doubt there are some trade-offs in all that. But by and large, I agree. The iterative nature of, releases, in itself is helpful. Just defending them at runtime nonetheless remains, a key area. And so with that, I think there's a lot of great progress here. Sam, we're going to wrap up, but I want to put you both on the spot with one final question for each of you to answer. And as you think about, the contested environment, what's at stake, the national security implications, the expansion of the domain in general, the security requirements, the unique requirements, the repurposing of assets, and everything else, are you optimistic or pessimistic about securing space assets? And how far do we have to go to really get to where good enough is good enough, or are we way beyond that already today? So over to you, either Sam or Dean, to go first. Are you optimistic or pessimistic?
Dean, go over to you.
I am somewhat optimistic. That's a non-denial denial. The reason I'm somewhat optimistic is, again, because the technologies that we have at our disposal to use to create trustworthy mechanisms, like a run safe, like a TPM, or like a trusted execution environment, we have some of the basic building blocks. The question is, are we going to use them? And that comes back to the question of cost performance and weight performance and all the things that go along with that. So, Sam's point of launching more satellites quicker is a great idea, but the reality is that they're still there for a period of time. And our ability to update their missions and change out their software functions in those operative periods is still important to us, and enhances the value of the space asset even further when we can do that at a relative level of security. Do we have that capacity today? Again, I would tell you that we have a little bit. At least we're not sending unencrypted communications from the ground stations any longer, because that was a way of many years, right? Now we're starting to really think about bidirectional secure communications between the ground and space. And what do we convey in that? Are we conveying it as a function of single point in time when we first handshake with the device? Or are we doing that iteratively throughout the communications protocol with the device? So these are all things that are being developed and that are being deployed. How effective they will be, it's like anything else in cyber. There's no one size fits all. There's no guarantee that this will withhold forever, because it won't. We've got a lot of things on the event horizon. Like I said, quantum is right around the corner, and that takes a whole different aspect to this, right? Because basically all of our encryption methodologies are at risk using quantum breaking type technologies. So are we going to, today, quantum resistance is a very heavy duty function. It's not a simple, easy to use function. So when we talk about space and quantum, we're going to have to find better ways to do that. Until we can get there, we're going to put some things at risk again. But the reality is that's okay, right? As long as we have some mechanisms to put trust in, and we can measure that trust, and we can use that trust effectively, I think we're on the right direction.
Very good. Sam, the floor is yours.
Thank you. And I think Dean framed it very well. I'm cautiously optimistic. Here's where let me give you the optimistic part and then the caution part. So the optimistic part is a lot of people are paying attention to this. SPD5, the National Space Council, that's a good step forward. The upcoming executive order, I think, is a step forward. A lot of people are working their hearts out on this. The Space ISAC is. Aerospace Corporation, where I work, is laser focused on the cybersecurity of space systems. The IEEE working on standards for the cybersecurity of space systems. Council on Foreign Relations, where I'm a member, has a task force looking at space management policy. Perhaps we'll also have recommendations here. So this is where I'm optimistic. People are paying attention. They know it's important. Here's the cautious part. We have yet to declare that our space systems are a critical infrastructure sector. And therefore, we have yet to determine that there is a specific sector risk management and agency in government that acts as the anchor point for the public sector in working across, on a whole of country basis, including with whole of nation basis, including with industry. And we have yet, since we haven't made this declaration, have said that our space systems are in essence a red line. We haven't said so. We've said that we know that all our other critical infrastructures depend on space. But what we've also said is that each of those infrastructures will take care of the cybersecurity of the space systems on which they depend. When everybody's in charge, who's in charge? So it's time for us to make that declaration that our space systems are a critical infrastructure sector. to designate a sector risk management agency, to give it the resources and authority to do its job, to make it a heavyweight counterpart to working with the private sector. This is where I'm cautious. I think it will happen. I wish it would have happened by now. Hopefully it will happen in the not too late future while we are all still drawing breath. So as I said, I'm cautiously optimistic, and I end with that caution. Thank you, Joe.
Well, thank you both. And I'm optimistic with both of you playing a role that you do to help advance the needs of the industry and the domain. And I'm also optimistic with your leadership, Sam, to push some of those things forward. And let's hope that it does get designated as one aspect of critical infrastructure once and for all. And with that said, I have stars in my eyes for both of you. You both are fantastic contributors to making the world safe and beyond. And so thank you for being on the webinar today. And thank you for your comments. And also thank you for all that you do. So we are a wrap. And for the audience, we will send some follow-up items with some highlights. We appreciate all the attendance we've had at the webinars throughout the month. And with that, Olivia, I think we're finished.